Good morning, students. In today's video, we are going to study this topic, concepts of isostasy. So basically, this is the new chapter. In the previous three chapters that we have covered so far, chapter 1 is about the origin of earth and all, in which we have read several theories. We have talked about the universe, galaxies, solar system, etc. So we talk about everything outside the earth. In the chapter 2, we talk about the earth. Okay, earth, a living planet, the different type of spheres: geosphere, biosphere, atmosphere, hydrosphere, lithosphere, ecosystems, biomes, etc. And in the chapter 3, we have talk about the earth's interior, from earth to earth's interior, inside the earth. Okay, so we talk about several theories, as well as earth. We have talked about like the different layers, internal structure, different layers present inside the earth, that is crust, mantle, core, etc. Okay, and now this chapter 4 is little bit different from the previous chapters, and it is related to the isostasy. So uh, let's see what is isostasy. So isostasy is the balance between the earth's lithosphere and the asthenosphere. So basically, isostasy is the balance between the earth's lithosphere and the asthenosphere. So the earth lithosphere contains the crust, the uppermost layer of the earth. Just below is the asthenosphere, and it is little bit softer and fluid like. Okay, think of it like floating, just like wood floats in water depending on its density. So this crust is still floating on this asthenosphere. We can think of it like the wood that flows on the water. Okay, and it depends on the density, that whether it will float or sink down. So similarly, isostasy is this balance between the crust and the asthenosphere. Why does the earth's surface move up and down? When weight is added, sorry. So when we so now let's talk about like why this the earth's surface, why it's not flat, why it's move up and down. So it's because when the weight is added like ice mountain, the crust sinks. So if you have a heavy object on the earth's surface, it will uh, sink, or if it is light, it the earth's surface will be flat. When weight is removed, the crust rises. Okay, so when you remove the weight from it, the crust came back to the normal position. This happens because the lithosphere floats on the asthenosphere. So this happens because the lithosphere floats on this asthenosphere. So this layer is very soft and fluid like. So if we have any heavy object on the earth's crust, it will sink down. If we don't have any heavier object, then it will came back to the normal position. So I hope this is pretty much based on the common sense. Archimedes principle on earth. So the same rule that makes boat float also applies to the earth's crust. Low density crust floats higher, high density crust sinks lower. So this here we can see the Archimedes principle. Archimedes principle applied here, that the high density crust will sink down and the low density crust will float. And the meaning of isostasy, so Earth's gravity makes crust segments move up or down until they reach balance according to their densities. So this Earth's gravity makes this the crust, the upper segment up and down, okay, until they reach the balance according to their densities. So means this isostasis basically what happens because of the Earth's gravity. These crust segments move up and down, and they move up and down not infinitely until the they settle according to their densities, okay. So this is called the isostasy, this balance that is created. Main idea is wherever equilibrium exists, mass above the surface is equals to mass below the surface, balance is maintained. So the isostasy is all about this balance in the earth crust and the asthenosphere, the layer just below it. Early belief about earth's shape. So let's see that what are the early beliefs about this earth shapes. So people first thought earth was a perfect sphere. So what does the people thought that this earth was a perfect sphere? Later experiments showed earth is an oblate spheroid, flattened at poles, bulged at equator. So after some experiments, uh, earth after some experiment, we came to the conclusions, or we can say the scientists come to the conclusions that the earth is oblate. So this is called the oblate, and this shape is called the prolate. So after some experiments, we came to know that the earth is oblate, and we can see this bulge at equator. Okay, this bulge, this outward structure, this is called the bulge at the equator. Prolate versus oblate. So prolate is this, no, prolate is this, is stretched up and down, and oblate is stretched sideways. Latitude and shape. Let's talk about the latitude and the shape. If earth were prolate, degree of latitude would be shorter at poles. On an oblate earth, degree of latitude is longer at poles, okay. So if we talk about this prolate, in this degree of latitude, meaning that if we go from one latitude to the another latitude, the distance will be much shorter than in the oblate. Oblate, the distance is much bigger, as we can see, it is stretched out, and in the prolate it is little bit more compact. So because of that, this distance between the latitudes, two latitudes, stretches out as comparison to the prolate. So experiments happen in the Peru, Ecuador. This is a place name. Scientists measure stars and used instruments like the plump bob. So it is bob, as you all know. In the pendulum we have bob, I guess. So it's just a round structure. They found that earth is oblate, not spherical. So in this particular experiment also they found that earth is earth is oblate and not spherical. Andes mountain mystery. So this is Andes mountain mystery. So Andes is basically a mountain name just like the Himalayas. So the plump bob tilted slightly because mountains pulled it sideways due to gravity. So what happens is they have suspended this plump bob, and they see that this plump bob tilted slightly, okay. And why it happens? Because the mountains pulled it to a little bit sideways due to the gravity, but the calculated gravity pull wasn't too strong, something didn't add up. So but they see that this gravity is not that much that they expected, because mountains are very big, so why this gravity is too little. So the correct explanation comes that the mountains have deep roots made up of less dense rocks. So the mountains have the deep roots. You can think of it like icebergs. So if you see icebergs, they are very small above the surface and very large below the surface. So but the same applies to the mountains. But the thing is, these are less denser, okay, and because they are less dense, their gravitational pull is weaker than expected. So they are less dense, and because of this, their gravitational pull is weaker. So here we got the reason why that plum ball experience very little gravitation. Same observation in Himalayas. British surveyors found similar weaker gravitational attraction. So British surveyors found the similar weaker gravitational attraction, okay, in the Himalayas. So this is Andes mountain. They have found this plum bob experiment that explained that the gravitational pull is weaker, and similar thing happens in the Himalayas. This supported the idea of mountain roots and isostatic balance. So because of this, we came to know more about the mountains, because mountains are very big above the surface, so to balance that they should have very deep roots. Two important theories developed uh, okay, so two important theories developed with these observations. First is Airy's hypothesis, second is Pratt's hypothesis. So for now, just we go through over the definitions only, and we will cover the things in more detail later on in the upcoming videos. But for now, just read the definitions. So what does the Airy's hypothesis says? Mountains have deep roots, crust thickness varies, okay, and the press hypothesis says that the density changes with elevation, means height thicker doesn't always means deeper. So these are two hypotheses, means theories that they developed based on their observations, and we will cover them in more detail in upcoming videos. So today's homework is to make an image in your mind explaining this concept. So I want to improve your imagination, because Albert Einstein says that imagination is more important than knowledge. So with this, that's it for this video. Thanks for watching.